All right, so this is OOP, encapsulating state and behavior with classes. So, quick history lesson. The two kind of dominant paradigms. What we mean by paradigm is like way to organize code. This isn't necessarily you can do different things with them. They're just ways to think about and organize solutions to problems. The dominant paradigms are
functional programming
and object-oriented programming. These are not the only paradigms. There's also aspect-oriented programming and tons of other stuff. But a lot of them kind of fall on two sides of the spectrum. And both of them kind of rose to prominence in the 60s. And believe it or not, functional programming kind of won for a while. So functional programming is a far more mathematical approach to programming. The functions that you write are a lot less like the procedures that we do and a lot more like mathematical functions like f of x kind of stuff. And there's a lot of advantages to doing that way. We'll probably talk about some of those tomorrow. But what inevitably happened is it got super abstract and theoretical and bloated and kind of stopped being useful. So if I look at functional fantasy land, so it ended up being primarily this shit. So you'd use gross words like this to talk about everything. And so if you've ever heard somebody talk about a monad is an applicative in the category of functor. Yeah, there you go. So it quickly became very difficult to write programs in this and hard to bring new people into programming. And so old object-oriented programming started sneaking back up again in the 80s. And the idea with this is, what if we did this in a far more literate way? What if instead of trying to mimic mathematical functions with our software, we talked about nouns and the verbs that different nouns do to each other? And it's really like we have these kinds of encapsulated entities that we're going to call objects, and they pass messages back and forth. And then our programs are going to reflect our real-world understanding of the problem domain a lot closer. And so this ended up being the dominant paradigm, end of the 80s, all through the 90s, all through the aughts. And so Java, C#, Ruby, like all these are deeply like OOP-inspired languages. Now, the problem is towards the end of the aughts, OOP started getting abstract and theoretical and way up its own ass. And so what we ended up with was a thing called Enterprise FizzBuzz. So you guys know FizzBuzz, right? What's FizzBuzz?
It's like a standard programming test.
Yep. Do you remember what any of the characteristics of it are?
I can't remember which you turned into FizzBuzz or FizzBuzz, but it's like going through all the numbers and turning.
Yep.
3 is fizz, 5 is buzz.
Yeah.
Yep, there you go. So the idea is that with, it's kind of like the Voight comp test from Blade Runner to test whether somebody's a human. This is the way you test whether somebody's a programmer. You have to write a function that, like, given a number, if it's divisible by 3, it returns fizz. If it's divisible by 5, it returns buzz. If it's divisible by 3 and 5, it delivers FizzBuzz. Otherwise, it just returns the number. So you pass a bunch of numbers in, you end up with 1, 2, fizz, 4, buzz, etc. Enterprise, and like as you might imagine, there's all kinds of different solutions to that. There's clever one-liners. Most people do in about 10 lines or so, but that's the gist of it. FizzBuzz Enterprise Edition highlights what OOP did to this problem. So if we go over here, so It's got printers, strategy, string returners, visitors. You go over here. And so this class, public final class, FizzBuzz output generation context implements output generation context. Like, that's where we went with OOP. And so what, in the last 5 years or so, 5-10 years, we've started seeing a lean towards functional again. And it's kind of burning off some of the detritus of OOP. One of my favorite things about JavaScript is you can pretty seamlessly jump back and forth between them and get a lot of the benefits of both. So today, we're going to talk about this. And to kick us off, I'd like to turn the microphone over to Jesse Pope.
All right. So since we're going to be talking about classes, kind of a fun fact about object-oriented programming and what was happening in the 80s was a group of programmers got together to discuss whether or not you could make a gold standard on measuring general efficiency for how things are being programmed in object orientation. So they wrote this assessment, and then they ran a NASA program through it, and the NASA program that worked great had over 1,200 classes. So just kind of a fun little factoid there that, like, at the end of the day, you know, does it work is kind of a big question too. Okay, so with that, I am going to Slack you guys out the Mdn source on classes and have you take 6 minutes to read that to yourself, take some notes, and then just highlight what you think is important, and yeah, we'll start with that. So throw that in your Slack channel. All right. Nope. Cool. Timer for 6 minutes going. Cool. we got 3 minutes left. All right, about 1 minute. Okay. All right, so go ahead and take a minute to summarize what you noted as important from that article, and then we'll talk about it. So. And you can do that paper or your laptop, but just let's get a nice chunk of summary of everything we got from that. Yeah. Cool. So let's do a turn and talk. We'll do Tyler and Ethan, Jeremiah, Rob, Kat, Taylor will do Jackson. You guys discuss each other, Patrick.
Thanks a lot, David.
Is this Mdn? Classes are not supposed to be video. And it's like, I was kind of lost on what to go with my next project, so I just wanted to
You don't call it.
So this
Yeah.
This? I don't know. So it's saying like, when you create a rectangle, each time you create it, you have to pass it a height.
In developing
The height
class, or is it
of
just
that.
above it?
The way I understood it is like,
So this is like.
it's like you inherit another class.
Otherwise,
And then
then
you
you
see
see
where you're like, yeah, you're like,
Yeah,
it's
so
like
it's-
inherent class. Is how I understand it.
So I guess that's the
I'm
difference.
just wondering if like,
It's kind of like.
one class closes off completely,
Oh, I see.
and then the other weekends, or if it's like still open by classes on the side.
Wait, when you're in class, there's no so you don't have to say it's.
Item itself is created.
Oh, yeah.
Well, that's, you are saying it's a function.
Oh, it is closed off.
Yeah, but
So
you.
yeah, it's closed off.
Oh, yeah.
Because the line is.
So why would it come back?
It's like signing up with a parent-child relationship.
I guess we have been using that script on. Yeah. So child area of being like stock.
Oh, I see, here's what you said.
This, okay, this again, top of that. How silly is that?
Why would you?
Oh, because this is saying like self, you said that, it's like self dot count.
So why does this return an
Yeah.
object?
Nicole speak. Nicole speak.
This is supposed to be.
Because the function speak in the line class calls.
Maybe it's saying that it's an object.
So why did it get though?
And then this class
That.
was there.
So could you call this outside? Could you do square dot out area, or is it almost like
Yeah.
private?
Yep.
Oh, yeah, yeah, yeah.
I don't know. What's the?
But we're trying to figure out, like, why can't that work?
Yeah, it's like,
Define this
it's
without
how
code.
you use the project, it's really.
Is it just because it's already inside
It's like,
class? But typically when you're creating a method.
So like we made a ton of different stuff on JavaScript, so I like.
Hey.
All the things that I have like a key class that has like a tag, and I also have a core class.
Oh, so then why would we there?
Yeah, this is all JavaScript, so like, all of these
So we need those
instances
parentheses
of
though.
the core
See,
class.
yeah.
So it just like helps me like,
Well,
and set up this relationship, so like, if you're like an E flat minor, like the time,
This, which should
Yeah,
you're like the.
Oh, yeah, I see what you're
As
doing.
a class,
Yeah.
that's something that can change. This is actually the so much of something today.
I think so. So I think if you're helping to add stuff.
Yeah, it's just, it's the same thing as like creating relationships between like classes.
No, I think you're on that.
Instead of having to deal with.
Static is Are these variables?
Yeah, I made it like a function, so.
Yes.
Yeah.
Alright, so now that we've had time to discuss what's going on, Kyle's gonna.
And I can be
show you how to
like,
do all this stuff.
I can be like E minor dot like medians, and I can get like chords out. Sound file and like all, you know.
All right, let me look at the plan real quick. And cool. So, shut up. Hey, everybody. Let's talk about classes a little bit. So, tell me what came out of your reading, your writing, and your group discussion regarding classes.
There's kind of this like initialization that happens. It kind of reminds us of Ruby's.
Yeah. There's an initialization, and it's just like Ruby's. What's that initialization called? Constructor. Constructor is the OOP term for that. And in almost every OOP language, that method is called constructor. It's called initialize because they think they're being more clear in Ruby, but it's the exact same thing. But we call that a constructor. Cool. What else did you learn about classes?
They can like inherit.
Yep.
Extends.
Inherit with extends. So how did we inherit in Ruby?
Arrows.
Little arrow. Yep. We just use the extends keyword, does the exact same thing. Extends is probably more common. What else?
They're not hoisted.
They are not hoisted. What's hoisting?
You can call on it before you declare it in the code.
Indeed, because its declaration is hoisted to the top of the scope. Cool. What else?
There's prototype methods and static methods.
Prototype methods and static methods. Let's talk about static methods for a sec. What's a static method?
Specific to the class itself.
Yes. What do we know from Ruby that's similar to that? Self.all, those kinds of things. Again, static is the OOP like theory term for this. Something that's owned by the class methods, we call those static methods. And then our prototype methods are equivalent to instance methods. Nice. Now, JavaScript is a special kind of language, and in some ways this makes it a little bit difficult to do pure OOP stuff in. But when we talk about prototypes, that's not an OOP thing, not really. Prototypes are a JavaScript thing. So when we do classical inheritance, that doesn't mean old, that means class-based. We say, all right, I've got a mammal, and I'm making a dog that inherits from mammal. And so what I really have is everything that mammal had and everything that dog has. And dog can overwrite anything that was in mammal, but they're one great big thing. So we'll call this classical inheritance. The other way you can do this is, all right, if I call a method on dog that isn't defined on dog, I look at its prototype and see that if it has it. And if that doesn't have it, I look at its prototype. And if that doesn't happen, I look at its prototype all the way up to object, which is the top level prototype. If object doesn't have it, nothing else did, then it throws a reference error. Slightly different. You do all the same things with it, kind of, sort of, but instead of having one great big object that has all of these things in it, because mammal can inherit from something, something else can inherit something, which leads to a classic OOP joke. All I wanted was a banana, and I got the banana, the gorilla, and the whole goddamn jungle. This is the whole jungle. With prototypal inheritance, all of these things are discrete, don't have anything to do with each other, can change at runtime, all sorts of stuff. But if we call something that doesn't exist on one, we just look up the chain. Pretty academic difference, but somebody will ask you that in an interview someday. What else did you take away from classes?
Question?
Yeah.
Prototypal?
Yeah.
So you said each relationship is isolated, it's like a blockchain, you said? So like,
Kind of, yeah.
you could, I don't even know what that means, but so it's like dog only knows about mammal, mammal only knows about
Correct.
dog. Okay.
Exactly. Anything else you learned about classes?
You can, like make new functions after your, like, little thing is done.
Mhm.
Block.
We can add, well, say method. So if we talked about procedure versus function versus method, so we can add methods after instantiation. That's a JavaScript thing. That's not an OOP thing. Okay, so procedure, function, method. These are similar but not the same. And we've been kind of using them interchangeably, but I think we're grown up enough to finally learn the difference. Anybody want to take a stab at what any of these mean?
You have to, like, invoke a function explicitly.
You have to explicitly invoke all three of them. Good guess.
Yeah. Does one have a more mathematical slant than the other ones?
Yes. Function is more mathematical than the other two. Yeah.
Is scope part of it?
No.
What about how they're carried out?
Sort of. Yeah.
What they're in relation to, what you're calling them with.
Yes. Method in particular.
I cheated using it. What they return is much different.
Indeed. What's a function return?
Something you tell it to.
So a function is input. The function does some kind of transformation and gives you an output. That's it. It can't read in variables that weren't explicitly passed to it. It can't affect variables that weren't explicitly owned by it. All it can do is take in an input, give you an output. That's a function. To use that f of x example from earlier, if we say f of x equals mx plus b, it's the linear equation, right? So we're saying is if I pass in x, I get this in response. That should be deterministic. It should get the exact same value every single time I pass that in. I should be able to plot out the results of that on a line. That's a function. A procedure is repeated behavior. A lot of times we're just writing procedures. So this can absolutely affect an outside variable. Read it in, affect it, print stuff to the screen, all that sort of stuff. If we want to wrap it up in a nice bow so that we can just call it whenever we want to, strictly speaking, that's a procedure. A method is a procedure owned by an object. So an OOP in all of Ruby, none of those are functions. Those are all methods. And when we're making classes, the things that we declare on those are methods. Cool. Anything else you take away from classes?
They can be named or unnamed.
Ooh, it can. An unnamed one is typically called an anonymous. class. Anonymous moose. Cool. Anything else? Neat. Let's see how they work. Dumb calculator, can't get away from it. Class magic. All right, so if I want to make a class, give me a noun. Give me a noun. Beer. So I make a beer class. So just like in Ruby, I might want to make a constructor that takes in a name and an ABV. And just like Ruby, I might want to save those to the instance. So I'll do this.name equals name, this.abv equals ABV. Good so far? And then I don't need to make accessors. JavaScript doesn't make us do that. Yeah.
So this name is just, you have this and you're appending the object, or the object relationship of name. So you're just adding the key of to this.
This is exactly the same as that was in Ruby. And other than that, this and self are 80% equivalent in JavaScript and Ruby. JavaScript's this is infinitely more complicated than Ruby's self, but they serve the same purpose. Okay, so I make a new beer, I take those things in, I save those instance variables, and then I can make methods like, I can give it a burp method. And what burp does is it console logs this beer is this.name and it's cool. Let's see. And then I'm going to make a new beer. So in Ruby, we would do something like PBR equals beer.new. In JavaScript and in most languages, we just flip that around. We say new beer, and then we invoke it like a function. And we say Pabst Blue Ribbon, which has an ABV of 1. I don't know. Not much. And then I call pbr.burp. So if I run this file, it does that. Tyler can't fucking take this shit anymore. Hates OOP.
It's too much.
So a couple like things that will trip you up at some point. Notice how there's not a comma right here. The class isn't an object. It's not the same kind of syntax. You don't put commas between them. Also, it's not a function body. I can't just do whatever I want. I can't write arbitrary expressions in the middle of this. That doesn't work. I can store things that like weren't in the constructor. I can make static methods that would be called onBeer. So I'm gonna call this one dinner bell. and it says it's beer time. And so I should be able to do something like beer dot dinner bell and invoke it. It's beer time. I can also declare like instance variables that aren't in the constructor. I can say something like let's see, is brewing equals true. I think that'll work. And then if I say PBR console.log PBR.isBrewing. Shoot, maybe I can't do that. No, maybe I have to do static first. In that case, it would be, that might just be a goofy React thing that you can do. I'm gonna check that. Nope, doesn't work either. All right, forget that. Don't worry about it.
They logged online.
Oh, really? Cool. So we can construct stuff. We can make instance methods. We can make class methods. One thing I will caution you about, though, is when your methods start calling each other, that's where you're going to run into some trouble. That's harder than it is in Ruby. So if I have something like build message or print message, and what print message does is it builds a message and then it burps it. So this ends up coming in, actually, it says this dot message equals that, and then calls burp with this dot burp, and I try to console log this dot message. Watch this. Oh shoot, it worked. Shouldn't have. Fuck, maybe they fixed that. Interesting. So a common issue is that if the outside calls print message, which calls this, and you have this, since burp was called by print message rather than from the outside, the this context can change. Be careful about that. You want to do it in React a ton. Cool, that's neat. All right, questions so far about class syntax? Yeah.
Were you just declaring message right there when you were making that?
Yep, exactly. It wasn't initialized in a constructor or anything like that. So we can absolutely do that. You can make new properties.
If you do that though within the method, would it be accessible to a class method?
No, this works the same way Ruby does. Class methods can't see instance methods. Instance methods can't see class methods. That's pretty standard in OOP. What else? Yeah, I'm
It's gonna be a really silly question, but so before you did this dot message and you say equals, this is referring to the fact that it's inside of a function. Right.
And it's hard to explain something without using the word this. In the beer instance, this refers to that instance. So this is referring to PBR.
Like the cell.
Exactly. That's why when we make a new beer, that beer's name, that beer's ABV. The problem in JavaScript is that this also can mean 8 other things, literally. So it's kind of like JavaScript the worst part.
If you did that within the static dinner building and you declared it this dot something, that would refer to the class then beer.
Yeah. So if I do this, I'm kind of curious what will happen. So if I console log beer dot is bell rung, maybe as I don't think it explicitly supports static properties. I know that's been a proposal for a while. So I'm curious if this works. What I'm expecting is that it's going to log undefined, and then it's going to log its beer time, and then it's going to log true. That's my guess. Oops, it's going to be on beer. That's right. Undefined, it's beer time, true. Cool. Other questions about any of this? Yeah.
Could you save a number? Like if you had all your oh yeah, you guys would do that. Never mind. Yeah, like instead of true, it could just be like this dot standard beer, the average ABV, all beers equals
Yep.
5.5.
Absolutely. And you could do the same kind of shit that you do in Ruby where like you maybe have an all that you're accumulating into, and then you can see all the instances you've made and that kind of thing.
There's no way to define what type it is unless you're doing TypeScript.
Correct. Now, one of the cool things is that if I'm going to copy all of this and open up a console and paste this in. Cool. So now I have this beer around, and if I do PBR, let's see, proto, no, prototype, no. Let's see, that one. See, that's the thing with all the shit on it. PBR. You can do is prototype of, and then pass in the class. Oh, it should be. Fuck, it's something like that. I don't use it a ton. I think class is one of like the most broken things in JavaScript personally, but it's worth being familiar with, especially for React. But you can do similar type kinds of things by trying to look for things that are in their prototype chain. But no, like other than that, there's no types of that TypeScript. Jackson.
When are you most inclined to use classes?
For client-side data modeling, or I guess server-side data modeling in Node. So similar to how you guys used Active Record, you can do a similar thing on the front end. And you can also do that in Node. So if I have entities that I don't want like my app to have to worry about how it gets to the database. I want that like object to worry about how it gets to the database. I think classes are great for that. And to give you an example of what that looks like in production, the develop Denver client so this is an event. So this would be like a talk or a lightning talk or a workshop or something like that. So I have a model that everything inherits from, and that looks like this. And so a lot of what this is coming up with these serializers and deserializers and ways to build the URL and kind of abstracting out how I want the models to interact with my backend. And then I can have a particular thing inherit from that, and it only needs to do the things that are specific to that. And yeah, so I think classes end up being pretty good for that kind of thing. And I did something similar on the server too. So on the server, most of this is around databases. So I'm saying, here's how you list something. Here's how you find a single thing. It's like a lot like Active Record, honestly. And every model has those just for free. And so then if I make something like an event, fucking Brian. So he overwrote the list with something that did not need to have. But I can also do something like event.update or event.delete, and it's going to look for that definition on the model. I think classes kill it for that kind of shit. You can also use classes, just like we did in Rails, for things like controllers and stuff like that. I don't think they're actually particularly good at that. Good question. What else? Cool. So let's take a look at the assessment for this standard. So we want to create a Pokemon class that stores a Pokemon's name, image URL, and list of abilities. We want a method called createCard that generates a DOM node that kind of looks like that. We want to be able to fetch a list of Pokemon using the Pokemon API. We want to be able to create new instances of the Pokemon class for every Pokemon we retrieve. We want to generate cards for each one and then add them as list items. So we're going to do the first part of this together, and then you're going to do the rest on your own. How about, let's see, so I'm going to be working with a DOM, so I want an index.html. Cool. And over here in app.js land, start from scratch. So create a Pokemon class that stores a Pokemon's name, image URL, and list of abilities. So I want you to think about how you would approach this first step. Cool. Taylor, how would I start?
Probably get that structure kind of built out with the declaring the class Pokemon.
Okay.
Starting with the constructor, adding some of the variables.
Cool. Name, image URL, abilities. Cool. Thank you very much. Luke, what do I do next?
This dot name equals name.
Yep. Okay, cool. So I think that first thing, it's in pretty good shape. Let's see. Rob, talk me through how create card. Give me a way that we could do this.
Well, we already have the, do we have to build it in HTML or do we want to build it in JavaScript?
So we want to be able to say, hey, Pokemon, make a card. And it uses all these things that it knows to give me something that kind of looks like this. Some kind of DOM node.
Okay. Well, I don't think I'm going to do that in this class setting.
Okay, so let's small the problem a little bit. If I just want to add a method called create card, how do I do that?
So function create card
Not function,
static.
not static. You just write the name of it. This is a thing that's different in classes. So if it's, see, create card, we just write create card and we put the parentheses in there and we put that in there. There's no function keyword. That's another thing that will trip you up at some point. All right, so we have a method called create card, and then Rob, what's it asking me to do?
We're going to take the, take the name, the image, and the abilities and throw them into the card.
Okay, like even higher level than that, we're generating a DOM node. So like maybe think about this from a sandwich standpoint.
So on an H1 for name, create a DOM node for an H1 to put the name into.
Oop, that's not an H1, that's a P. But even before we get there, we can say something like, we'll call that card. We document dot create element, and the outer thing is a div. And then this part is a little bit different than we usually do with stuff we've done in JavaScript so far. We're trying to generate a DOM node. We have two ways. So let's assume we've generated it. We have two things we can do. We can return it out of the method. That's normal. We can also store it on the instance. In this case, I'm going to say let's return it. But there's a lot of stuff you do in object-oriented programming where you're just manipulating the state of a particular object. It's much less based around like what you pass into something and what you return it. It's like in functional, we would pass in name, image, URL, and abilities. But since they're owned by this particular Pokemon, we just reference them through this. All right, so I'm going to say we're going to return in here, and then whatever we do has to be something in between there. So Ethan, give me some ideas for how I can bridge the gap between these two.
Card, set the internet HTML.
Like the way you think. Somebody remembers the refactoring lesson from yesterday. It's practically cheating. So we can say the card's inner HTML is all this shit. Pretty cool. So since I'm using the string interpolation here, I can say something like this.name, this.image URL. Ooh, but this gets tricky. I don't know how many abilities there are going to be in here. So I can't write them all out ahead of time. Oof. So we're part of the way there. Ahmed, how you think, now that I've done this, I've got 5 abilities, how am I going to add them to this card that we're making?
Let me guess, I'm going to use something that takes in a number and returns the same number.
Yep.
So like a map?
Okay, so map it.
Oh,
Keep
for
going.
the abilities? Oh, okay, so I'm going to go, where are we? This dot abilities dot map.
Okay.
Open it up. I'm going to say ability. Yep. Now we're going to say li.
Return what?
An li with what is it?
Explain li. We need to get li's, that's what we're trying to put in here. But just type li.
Oh, you're going to do less than caret li. So like HTML tag and then close. Yep. And then you're going to do ability. And then close your line. Is ability, what is ability? Is it a string?
Ability is a string here. Can I do that?
The whole thing needs to be a string, except
Okay.
for what you're interpolating.
So yeah, I could do that as a, well, let's see. Range surrounding.
And then you can join it, join that.
Oh. It's kind of a clever solution to that, Patrick. So I map through each of those, and now I have an array of these strings. Patrick thinks I should join them, so I get one string. So I could do something like join. Pro tip, I could also reduce that. Start with an empty string and then just keep concatenating to it. Concatenating to it. Kind of like Patrick's better though.
Would that join your joining each li?
Mm-hmm.
String? Okay.
So I have an array of strings and I'm making them one string. And since this is really just that one line, how about yeah, now we're getting somewhere. That progressive refactoring, I like it. All right, Ahmed. So I've mapped, I've joined, I have this string of li's. So what do I do with it?
Const abilities equals the set abilities. Yeah.
Okay.
And then inside of card.image.html, underneath the image, or no, between the ULs tags, we're going to do interpolation of abilities.
Well, I need to put that there then, right?
Yes.
That's a clever solution to that. Can we think of another way we could have done this? Same thing? Yeah, Tyler.
I would have basically just like done a for each on this abilities, created a list element for each ability,
Mm-hmm.
and then set that text content to the string itself, and then append that list item to the
Yes. Because, remember, never forget, we can do card.querySelector UL and then append things to that. It's not just document. Any element we can do query selector on. Pretty baller. All right, this works though. I like it. So we've got abilities. We've got this card kind of built out. There's one other thing that we needed to really make it kind of look like that. Class. And anyone remember the way that Old Man Coberly likes us to add classes?
Card dot class
Mm.
name.
Classlist.add.
Thank you.
What does that do?
Adds
As
a class.
a class.
So instead of,
It adds the period before you start.
Can you also just do class name equals?
So if I do class name equals, I'm saying I want the class to be this. In this case, that doesn't make a difference. The reason I'd caution you against doing that is that someday, somehow, you are going to say class name equals, and you're going to overwrite classes that are already there. You don't want to do that. All you want to do is make sure that it also has this class. Also, I think that reads semantically more correct. Because you can also say something like card.className equals, this may not be all the way obvious to you, another class, yet another class. So we can put 3 classes on it that way. I'd much rather call add 3 times. Yeah.
So, say you have an HTML element that you're selecting,
Mhm.
When it's noted with the space, does class list automatically read those things as an array?
Say that again?
I guess my question is getting down to the translation between HTML
Mhm.
and JavaScript.
Okay.
Is class list an array of things, or is it just?
It's a class list. It's
just
a special
class-
kind of thing.
It's a special, so it always puts that space in. Okay,
Yeah.
cool.
And like that's the coolest part about it. You actually don't need to know how the fuck it works. It just makes sure that it also has that class. All right. And then if I return card, I'll bet this is in pretty good shape. So I've got this this cool ass Pokemon class. It can create cards. And then we also want it to be able to fetch a list of Pokemon. We want to be able to create a new instance of the Pokemon class for every one we retrieve. We want to make those cards, and we want to add each one of them as list items to that. Fetch a list of Pokemon using the Pokemon API. Hey! If I want to, how am I going to do this? I'll think about it for a sec. I'm going to fetch a list of Pokemon using the Pokemon API. Jeremiah, how do you think I'm going to do that?
I would make a function outside of the class
Okay. What's it called?
called fetch Pokemon.
All right. Okay, what's it do?
And it would start with fetch to
Okay.
and it would dot then response JSON.
Okay.
And then it would dot then, and now we have our list of Pokemon. So that's step 1.
Okay. Okay, who can help Jeremiah figure out how we make an instance of Pokemon for each one? Ethan.
I'm gonna do a Pokemon.forEach, and then make an object, and then call.
For each? Or if I have a list of 5 Pokemon that came back from this, how many Pokemon instances do I want? 5.
Map it out.
Map's probably a little better at that. Keep going, Ethan.
Yeah, Pokemon type just comps, Pokemon equals whatever that class name, or new class name. And then, P dot create card, and you have to pass in those attributes.
Yeah. So it's name, image URL, and abilities. Sprites, front, default. And then if I want just a list of string abilities, let's take a look at what I'm getting back from this. Pokemon list.map is not a function. All right, so. Oh, what is that? So it looks like I'm getting an object back from this, not a list.
You didn't do an
What about this one? V2, Pokemans. There we go. Oh shoot, it doesn't give you the actual, the details on them. It just gives you links for how to get those. I think we found a way around this once. Does anybody remember what it was? So we don't have to recursively go through each of these, although that'd be kind of fun too.
Didn't we slap an index on the end of each fetch?
So it gives you the count at the top node.
Yeah, all right, I don't think it's going to actually help me out too much. That's fine. We'll do it with 1 at least. We go to Bulbasaur, neat. Say, oh, Pikachu. So we get back Pikachu. And not mapping anymore. So we say, well, Pokemon.name, Pokemon sprites front default, and for those abilities, right now, we get an array. We just want that name. So I have 3 abilities, 2 abilities, something like that. So what do I want to do to just get the list of names? What was that, Kat?
Abilities.
Okay.
Dot abilities. Dot map.
And then what's my map do?
It will give you an array the abilities?
That's the thing I'm mapping over.
Oh.
So I'm going to call a function on this and this. What should that function do to give me the name?
If you're calling it P, then P dot ability dot name.
There you go. That's what I'm looking for. P.ability.name. That should give me a list of abilities that I can pass in. Cool. So now I have a list of Pokemans. And my goal was fetch a list of Pokemon. Done. Create a new instance of Pokemon class for every Pokemon you retrieve. Done. Generate cards for each one and add them as list items. So let's see. Tyler, any ideas on how I can take my newfound Pokemans and make list items out of them? Make cards, list items, throw them on the page?
Can we just call b dot and then whatever that function was for the card? And then
P dot create card.
create card.
Okay. So now I have this DOM element. Now what?
And we want to append it to that UL, that we set for it.
This is giving me a div. Only legal child of a UL is an LI.
So we won't create that LI.
Yeah. All right.
And then
What do I do?
we want to append that whole thing to the LI.
Okay. Neat. Now what?
And then, you want to append that LI to the, UL that we have set first. I think it's just called Pokemon, class is just Pokemon, right?
Something like that. Pokemon. UL document dot query selector Pokemans.
We have dot in front of Pokemon, for query stuff.
Good catch. Uh-oh. Unexpected error. Let's see what I got back. Oops, because I got the URL wrong.
.com?
So, refactor time. All of this lives outside the class. The thing we're trying to do, encapsulate state and behavior. Doesn't feel like we're encapsulating. Something broke out of the capsule. So fetch Pokemon.
Can you just move that whole thing in there?
Okay. But if I do that, I need to make a Pokemon before I can fetch the uh-oh. But I'm making a Pokemon in this. How can I handle that?
Refactor the big Pokemon and fetch separate first.
Yeah, you can do that. Any other ideas?
The issue is you're making Pokemon before.
Yeah, I can't. I mean, I'm making a Pokemon with this thing. It wouldn't make any sense to make a Pokemon and then have it make Pokemon for me.
Another class?
Could make another class. Or one other tool at our disposal.
This.
static. So let's start by throwing all this into a static method. Now I can call Pokemon.fetch Pokemon. Sounds repetitive. Let's just call it fetch. And now let's take a look at what this is doing. I could even say it takes in a name, maybe. And that name gets passed in there. Okay, parse the response, we get their abilities out. We make the new instance. We make a card, throw it on the page. All right. So now I wonder if I can, instead of calling fetch Pokemon, call Pokemon.fetch Pikachu. And really, I'm not just fetching anymore. I'm doing a few things. What's the ultimate goal of this function?
Display Pokemon?
Sure. Display.
I guess, well,
I'd probably say render. Yeah, display. Display's good.
I could display, I think.
Okay. And then assignment to undeclared variable li. Aha! Too much fucking Ruby, man.
It tosses an error for that?
In classes.
Wow.
Because this never should have been part of JavaScript. It's a mistake. And so, like, further developments in JavaScript catch that a lot better. And now you know the power of classes. Furthermore, I can do Pokemon dot display Pichu. There he is. It is pretty sick. And with the skills you already have, you could probably make a form or something. You read a name out of that and make whoever the fuck you want show up on the page. And coolest part of this, all of this is wrapped up in this nice little Pokemon package. So you have access to that class, you have access to all the cool things the class does. Encapsulating state and behavior with classes. What questions do you have?
But you can like use both back and forth. Like say if you choose to use classes, you don't have to put everything in classes. You can do class and functional.
Yeah. I could do, so did all of those things. Now, what if I'm trying to think of like the most obnoxiously functional thing I can think of.
It's not like CMS taboo or anything. Like bad practice.
No, it's like the coolest thing about JavaScript, best of both worlds. I would be intentional about when you're using one or the other, and I think you can haphazardly slip between them and do things like you're returning variables sometimes, you're setting state on the object sometimes, and it's never clear why or how you do which. That can get a little bit goofy. Good question. What else? Yeah.
So if we went back to that console, we went to back to that Pichu, and we called that a variable in the console,
Mhm.
play around with all this stuff.
ditto. Oh, this will be interesting. So if I go ditto, why? Why did that happen?
Pokemon display isn't returned.
Cool. So I could, out of all this. Oh, by the way, I don't know if you realized this, but once you're in a promise chain, you can just keep chaining shit. So like, I could do something like that, and then return that. So if you just want to break that up more, like the value of this first argument is always whatever was returned from the last .then. It's pretty baller. So we can do that, and then if we return that out of the final call there, we're actually going to end up with a slightly different problem, but it'll be interesting. So if I do that, oops.
What we have to do.
Oh, that should. Oh, I see why. All right, so if I make ditto, no, there we go. Now I have a promise because I have that chain. So now I need to resolve that promise. So I need to do ditto dot then, and then I get the Pokemon. Pokemon dot then Pokemon. Cool. Oh, it's still a promise? It shouldn't be. Oh, it's because it did that. Shoot. Oh, it's still the promise, but it's fulfilled. Yeah, I need to have it inside the handler for that. I want to try one more thing, though. Okay. Okay, there's ditto. No, still brings back the promise. That's fine. But yeah, if I want to use that and like examine it and add other shit to it, it needs to be in the handler for that. Cool. What else? Another way I could have done this entire thing is that I initialize Pokemon with a name only, and then it has a like a fetch method that's an instance method. And I go, by the way, fetch all my shit. Then I have another method called display that isn't asynchronous, and I say, okay, whenever that comes back, now run the display method, and that'd be one way to do it. Other questions about encapsulating state and behavior with classes? Going once, going twice.
Can we just like re-go over state versus behavior?
Yes. So this has 3 pieces of state. What are they?
Just the attribute with the names.
Mhm.
Abilities.
Name, image URL, abilities. That's the state of any Pokemon object. Its behaviors are display and create card. Properties, state. Methods, behavior. Now, the thing that we didn't do, and this is what like this paradigm is kind of all about, is I didn't make a function called createCard that takes in a Pokemon and then returns the card. And then I didn't make one called display, and I didn't make a variable up here. So this isn't encapsulated. We have 3 separate fucking things just flying around out in the ether. With the classes, we keep all the related stuff together in one place. That's like the essence of OOP. Whereas this is actually the pretty good start for a functional approach to this problem, where we absolutely want completely separate independent functions that we just combine in unique ways to get the behavior that we want. But we're working with tiny little Legos, and the Legos turn into a pirate ship. With OOP, we're getting the frame of a pirate ship, and we're like, I don't know, applying the sides and coloring it in and that kind of stuff. Other questions about encapsulating state and behavior with classes?
Why do you like functional better?
Sure. So that's a great question. A really underappreciated nuance of programming is that when I do a variable declaration and then I do something with that, I've introduced the concept of time into my application. This happens, and then this happens. Good 80% of the bugs that you run into in programming are purely an issue of timing. Something didn't happen at the right time. Something happened before something else was supposed to happen, and that wasn't supposed to be the case. Something didn't happen when you needed something else to happen. Functional programming, by and large, does not have the concept of time.
The job shadow, I saw a real world representation, especially in like multi-threaded
Yes!
programming.
Yes!
There were 2 things going on at the same time. They got the same timestamp, and as a result, half the data was being lost.
Yes!
And you know, you had to find a way around that.
Yes. Functional programming doesn't have that issue. The closest thing that you've probably experienced by this no time thing is if you've done any spreadsheet programming. You program with spreadsheets before, you do cell calculations and stuff. There's no, well, you calculate this cell and then this cell and then this cell. You're just making statements of fact. You're saying this cell is 2 times what this cell is. I didn't tell you to calculate that or recalculate it or anything. I'm just saying that that's what this is. And when you combine all these functions, these little Lego pieces, in increasingly more complicated ways, you get tiny things that you can prove are true. Given this range of inputs, I will always get this range of outputs. And if all of them are just kind of evaluated without this concept of this, then this, then this, then this, we get much more secure programs. It's harder to break them because in a lot of ways they end up looking a lot more like mathematic proofs.
So functional doesn't have time until you call a function that invokes all the other ones, essentially. Then they'll run in order though.
So the core idea in functional is that a function execution is equivalent to its return value. You can just use them interchangeably. And so when I do a function that takes in another function, like these things do happen in an order, but in a lot of ways I'm saying that they don't matter. I'm saying that whatever this is and whatever this is, these two arguments, like if that evaluates to 1 and that evaluates to 2, and what this really does is add, I'm saying add 1 and 1, and what I'm really saying is 2, because these are all equivalent statements. That's powerful. It's really powerful. It's also a brain buster. OOP is, broadly speaking, a lot easier to wrap your head around because it's how humans talk about things naturally. Functional is not. It feels very alien and very foreign. But when I solve a problem with functional programming, I basically never have to look at it again. It just works. It like provably works.
So like, how does object-oriented have time in it then?
Because if we set aside the async thing, that's a little bit different. I'm saying set this variable and then do this. I could have also said, where I'm using like abilities here, this entire thing could have just been swapped out for wherever it's getting used. So I'm saving abilities, and then I'm passing it in here. I would just do this in here, no variable. And now it's an evaluation. There's no step there. It isn't 2 steps, it's one thing. And this is a statement of fact. It's completely interchangeable with like that, like a string that comes back from it, or the array of strings that comes back from it. And so it's like I just typed that out to begin with. So it's like there wasn't a step at all. You see why we save some of this heady theoretical bullshit for towards the end of the program? They're like, no kidding. That's how college programs work. They pepper you with all this crap, and then they're like, so you'll be able to figure out how to program now that you know all this theory. We'll talk about it more tomorrow, but this is equivalent to an array of strings. It's 2 ways of writing the exact same thing. And so if I put that expression there, it's like I typed that out to begin with. This is 2 different statements to the computer. The other one would be 1. Or another way to think of this, if statements. Functional programming doesn't have if statements. So instead of condition, if true, if false, what you would have instead is if is a function. And so you have condition, function to run if true, function to run if false. If you've done spreadsheet programming before, that's how you do conditionals in spreadsheets. And what's cool about this is that this, since it's a function, returns something. And this function that you run if it's true, like the return value of that is equivalent to like the function that you pass in here. And so there aren't actually any steps. They're just expressions that evaluate and evaluate and evaluate and evaluate. Versus this one, where it does this, and then it goes here, or it goes here. Another thing that's cool about this, I can test this function independently. I can test this function independently. I can't test this block independently. I can't test this block independently. And really, I think it's things like that that swung me over to the dark side. Because I was an OOP guy for a while. But when you have code like this, you've doubled the complexity of your application. Because now you need to account for conditions where this block executes and conditions where this block executes. I can write an automated test for either one of these, and I haven't actually increased the complexity of my application at all. I think that's pretty cool. Encapsulating state and behavior of classes. Going once. Twice. Sweet. I'm going to talk about APIs next. Let's take 5. Ah!